Hello and welcome to this week's What Were They Thinking? Among the news items we have for you this week is weird sea cucumber news, an interesting development with regards to the COVID-19 lab leak theory and the initial publications on it, the implications of drinking raw water and why it is a bad idea, a novel development in terms of first aid, or more accurately, combat aid, that's showing up in Ukraine and possibly may find its way into more common civilian use by paramedics during trauma. A tiny robot capable of isolating individual cells which could have huge ramifications for immunogenic therapies for cancer. An anecdotal discussion of the role parents have to play in medical care for transitioning children. The first genetically modified food commercially available, the purple tomato. The increasing number of diseases in America that are in the outbreak stage, including an interesting development in Michigan with a fungal disease. Unsurprising results of studies investigating whether or not widening a freeway or similar in America would actually be beneficial. Then there is an interesting response to a New York Times article about the role a crypto mining company has with the security and energy grid in Texas. Further evidence as to why our future robotic overlords probably aren't going to look very kindly on humanity. And the bizarre and rather counterintuitive thought experimental mathematical calculation that we found on Twitter. The timestamps for these and other news items can be found in the description box below. Let's start with sea cucumbers and the truly bizarre way they protect themselves from predators. What they do is that they fire off a sticky substance from their butt. This is honestly not that unusual. For example, squids fire off ink in order to hide themselves and scare away predators. The difference is the octopi, or octopuses as you're free to debate in the comments section below, are obviously more developed, larger, and theoretically able to make more conscious decisions. A sea cucumber really doesn't look anything more like a sausage, squirming along the floor of the ocean. The fact that it has a defensive mechanism is why it's interesting. But it's not just interesting because of that. What it's going to spit out is something called the Covarian organ, and they're basically spider silk but from a sea cucumber. It's made up of hundreds of little tubules, are attached to its butt, and that it spits out freely to try and deter any predator from consuming it. Going from bizarre to dumb, we have an article from the expose, and the gist of it is that it claims that 1 in every 310 people died within 48 days of receiving the first COVID-19 vaccine booster. Now, this sounds like a rather terrifying figure. The problem is that death rate is well below the background normal mortality rate of people. In short, they were claiming that the number of people dying within 48 days of being given the booster was unusual and therefore presumably caused by the vaccine. The problem with this is surprisingly simple and unfortunately obvious. The normal daily mortality rate is 0.002% of the population. The mortality rate according to this is 0.0004% of the population. This means that on an average day, you have 0.02% of the population dying each day. According to this study, you have 0.004% dying each day. That means that you have a huge difference, and as a result, you can't justifiably say, oh, but they were killed by the vaccine, because there's nothing to distinguish whether or not the vaccine was in any way, shape, or form responsible, let alone the idea that there was some kind of increase due to vaccinations or boosters. The reality is, there wasn't, and you need to always compare to the base level. If it doesn't go above the base level, there is no effect to be observed. In a similar vein of COVID-19 news, we do have a interesting development with regards to the lab leak theory. not interesting in that it actually provides any more evidence for or against it, but it is adding more detail. And specifically, it's focusing on the debunking of the lab leak theory, and how one of the people who was involved in writing the original debunking letter for the purposes of nature has actually got a rather uncomfortably close relationship with the Wuhan Institute of Virology. Now, we say involved in writing it, however, they're not a listed author, and this is where the problem lies. They're an unstated sort of ghostwriter or expert who was consulted for the purposes of writing the article, and as such, that they're not included in the article as either someone who's being recognized for their contribution or for their ability to contribute and therefore should have possibly been an author outright, was instead not included at all. And since they have close ties to the Wuhan Institute of Virology, who would be very negatively affected by the lab leak theory, you need to ask a lot of questions, and those questions aren't getting very good answers. Now, to be clear, we don't necessarily agree with all the content in this article. There are some areas where we're looking at this and thinking you're either overstating things, or there are possibly misunderstandings, or you haven't very well substantiated what is being said. However, even with that in mind, there are some issues that it raises that do warrant, let's say, greater consideration. Travelling further along the COVID-19 route for this week, we do find that the lawsuits brought against Pfizer have been dismissed. The short and simplified version of the lawsuit is that Ventavia was an organization contracted to run 3 of 160 sites that were used for the clinical trials for Pfizer's vaccine. These sites had 46,600 and some people across them. Ms. Jackson claims that the sites she was responsible for were apparently not running a clinical trial according to the proper procedures and protocols. That this in turn led her to raise these issues with her senior management. She also claims that by not running these clinical trials correctly, they were effectively defrauding the US government of money. By itself, none of these are things that she has standing to claim about herself. However, she was fired, and she claims that she was fired for having raised these concerns. This is where things get rather messy. She was fired and claims it was because of reporting issues, but the lawsuit she lodged was to recover the expenses the government had incurred in funding the clinical trial sites that she had been responsible for. It does seem that she also was seeking, to some extent, to have the emergency approval withdrawn for the vaccine. However, that's now pretty much redundant, as the vaccine is no longer using an emergency authorization, but is a properly approved and completely and normally acting drug in terms of the regulation around it. The judge dismissed it for the simple reason that Ms. Jackson had not been able to show a false claim for money by the defendants. That is, they did run those clinical trial sites, they did incur their costs, and they did exactly what they said they would do, even if Ms. Jackson does not think so. To address one of the other issues that is associated with this, even if these 3 sites with their roughly 1,600 individuals had been run incorrectly as claimed, and you then removed that data from the rest of the clinical trial, it still wouldn't change the results. Therefore, you wouldn't actually see any effect if this lawsuit had gone through and been successful. Simply put, there wouldn't have been any alteration in the outcome. It still would have been approved, just with a slightly smaller clinical trial size. That is because the other sites collectively demonstrated the same or similar enough results as makes no difference. This is important to note, as it does significantly undermine any attempts to sue based on either emergency authorization or on the idea of having misspent money. Shifting from anti-vaxxers to other trends, and specifically raw water. Raw water is a very dumb idea. It fundamentally takes the idea that water from nature, for whatever reason, is better for you. This isn't really true. There's a very good reason why water is one of the easiest ways to get things like cholera and more. And many, many decades, if not centuries, have been spent trying to make sure water supplies are reliable and safe, specifically by not being raw. And this is where a particular example from this week of raw water comes into play. The raw water in this case led to 19 people falling ill with diarrhea in Montana. The reason they fell ill is that the water had received no treatment in any way, shape or form. That is, it had not been filtered or otherwise processed. That would be fine, let's say, if, for example, it had been from a running stream or somewhere where there isn't an opportunity for any particular pathogens to build up. But no, in this case, it came from a source that was running under a bird's nest, and unfortunately birds' nests are well known for containing many different pathogens. This specific example was Campylobacter jejuni. The reason these people fell ill is that they thought it was from a natural spring, but the source of the water wasn't a natural spring at all. That would be unlikely to contain pathogens. But in this instance, it wasn't. It was a man-made device to drain water out of another area, and the bird's nest is the likely source of the contamination with that pathogen. The next bit of news we have for you is a similar kind of fad or trend. However, this one is likely a much longer running issue. It is the discovery of a box full of baked bats by German police. Yeah. This one took us by surprise. It's unknown what the man was intending to do with these bats or the boxes of uncooked and unrefrigerated fish he was carrying. As should be known from recent history, the idea of consuming bats is a very bad idea, as it is with any wild animal. Wild animals are a good way to get diseases, but then again, life seems to find a way regardless. And this week we have an uncomfortable case study involving the Chondrostereum purpureum, a plant fungus. The case study, though, is uncomfortable not because it's a fungal infection of a plant, but because it's a fungal infection of a human by a normally plant-predating fungus. The person in question managed to develop an abscess in their paratracheal region. This is the area running parallel to each side of your trachea or windpipe that leads into the lungs. The abscess was identified through the use of a CT scan that identified a mass, and that mass turns out to be the fungus. That was only established after they aspirated pus from said abscess. While not quite on par with the idea of the fungus from The Last of Us, we are getting ever closer and closer to clickers. At least in this case, the cure didn't involve killing a young girl, but rather it simply involved the use of a rather long-term antifungal. It was the use of a 2-medication regime twice a day for about 60 days. They were then cleared for about 2 years to make sure that no, they were definitely cured and that no, they weren't going to turn into a zombie, or something worse. In other medical news, we have the interesting anti-bleeding fabric being made from shrimp shells. Now, shrimp have a rather interesting exoskeleton around them. It's made from chitin, which is the same sort of thing that insects have around their body, or crabs and so on. All of these are not exactly exciting, other than the fact that they have their skeleton on the outside of their body. That is until you start using it in other applications. For example, the clotting fabric or anti-bleed fabric being used in Ukraine for soldiers and doctors working in the war zone. And these sorts of devices aren't exactly new, but they are interesting simply because of what they do. That is, you apply them like you would any packing for a wound. While you do that, the chitin within it turns into a gel-like clot, and this prevents further bleeding from occurring. Now, if you need to, you can remove them and you can repack the wound. The reason they're so popular with the military, and for that matter, emergency medics, is that they can stop bleeding within 60 seconds. This compares well and truly beyond favourably with normal clotting processes within the human body. Swinging back to more microbial pathogenic news, and the increasing number of flesh-eating microbes along the US coast. This is a combination of several different aspects that all build up together to an increased prevalence of these bacteria. The initial impetus is, well, oceans are full of bacteria, and depending on where you are, they can be more or less dangerous. The problem is then the environmental pressure selecting for more aggressive or pathogenic kinds of bacteria and other microbes, and this is basically climate change initiated. When you combine the increasing selection for more aggressive or pathogenic bacterium, the fact that oceans and beaches are a desirable place to be in, most humans tend to live along some sort of waterway, but especially coastal waters near the ocean, you find that there's an increased exposure to these rather pathogenic bacterium. And that's the issue here. The number of infections with a particularly nasty kind called V. vulnificus along the US East Coast went from 10 a year to 80 per year. The researchers expect that this will rise to somewhere around 200 in the next 70 years. Now, anyone who's played Plague Inc. would be familiar with the idea that if you make some of your microorganisms more resilient to the environment, they tend to also have resilience to things like medication and far more effective at infecting others, and this is true of life as much as it is video games. In this instance, the selective pressure of increased heat, environmental conditions in the ocean along with elsewhere is why we're seeing this particular increase in pathogenicity and infection by V. vulnificus. And the other effect that they report is that they see the prevalence with which it's occurring spreading northwards to areas where the ocean should normally be cooler and therefore less hospitable. And this is yet another concern. Well, that news may be worrying you, but there is some hope for other diseases. Specifically, the creation of a very tiny robot is able to locate and capture individual cells. By itself, that may not seem very useful. After all, what is a single cell going to do? Well, the key here is twofold. One, an individual cell can be used in all kinds of ways, whether it's reproductive purposes or for developing immunological responses. But the second element to this is the fact that they've created such a tiny robot, and that tiny robot could be used for other purposes. Rather than capturing cells, what if it instead delivered medication? Of course, none of this is possible without the tiny robot being able to move, and so that's why it needs what is called a micromotor. The micromotor is pretty much the key to this. Now that you have both a robot that can move and do lots of things, how do you control it? Well, the researchers are using either electric or magnetic fields to control this tiny robot, and that means that you could be using it in all kinds of ways all throughout the body. You don't necessarily need to be in a high-tech MRI machine, for instance, but rather you might be able to use a localized control remote, for example, something similar to an ECG or EKG. The robots themselves are between 5 and 27 micrometers, so we're talking really, really tiny here. Somewhere between 3 and 5 times the width of your standard red blood cell. So that means you can very effectively use these in the human body, as you're largely able to go just about anywhere you need to go. Of course, treatment is the worst option possible. It's better if you can prevent the need for treatment in the first place. And this is where another interesting study comes into play. It's evidence that walking at least 8,000 steps just a couple of days a week can significantly reduce your risk of death. Now, many people take things like the 10,000 steps a day challenge and try and live by it. Whether or not these particular challenges are worthwhile is a very different question. However, that's mostly because they lack evidence. This is where the researchers at least have something going for them. Their study is relatively small at 3,101 individuals, and they were looking at whether or not they were 20 and older, and whether or not they had data for walking 7 consecutive days. When they looked at the data, they found about 63% of participants had 8,000 or more steps for at least 3 days a week. And then the remainder had less than 8,000 steps a day, or at least per week. When they looked at this, the benefits are obvious for younger individuals who generally are more physically active. But what is somewhat important is for those over 65 years of age who do have a much higher cardiovascular disease risk, but also seem to have significantly more benefit than those who are younger. The other noteworthy part to this is that they had to have less exercise to get the same benefit. That is, they only need to do this 1 or 2 days a week, rather than 3 or more days a week. The next news we have for you is somewhat old, but it was brought to our attention and it's definitely worth mentioning. It's a fake clinical trial. Specifically, a fake clinical trial looking at using stem cells to restore vision. Yeah, this already sounds really dodgy, but the consequences are what's important here. The trial led to the blinding of a number of individuals. In fact, the 3 women who took part. The problem is, the clinical trial was actually stopped before it officially began, and this is where the problem lies. The reason it was stopped is not clear, but more than likely due to the fact that we have, at least at that time, no way to effectively differentiate cells. It may be less accurate to say that approximately 7 years later. However, there were still people recruited for this clinical trial, and that's a big issue. The clinical trial had been stopped, yet they still recruited individuals into this trial and conducted the treatment. Yeah, that's a big issue right away. The second issue is how they were proposing to get these stem cells. The idea was that they would take blood, separate out the blood cells and the plasma, and try and get stem cells from the blood. This doesn't exactly work as well as it used to, mostly because they found that there are better ways to get stem cells. So rather than trying to rely on finding a very small population of stem cells floating in blood, you can simply go directly to other cells and either get them to turn back into stem cells, or otherwise chemically treat them to force a reversion into stem cells. There's also the fact that, well, this method as it is may not necessarily lead to the development of the necessary cells in the eye to restore vision. That's because you don't have any way to guide the differentiation once they're in the eye, and this is one of the big reasons why there isn't clinical data supporting their use. The final big red flag is that to take part in the clinical trial, each participant paid $5,000 for it. And this is a big issue. Generally speaking, you don't pay to take part in clinical trials. It's, if anything, possibly the other way around. Further to that, the paperwork involved didn't contain any information about the registration of the clinical trial or the approval for the trial to happen. This means that you have some very big issues, and unfortunately it did lead to 3 individuals losing their eyesight as a result. Going from clinical trials that lack evidence to a clinical practice that may or may not be questionable at the moment depending on your point of view. That is the transgender transitioning of children. And the article from the Free Press is a anecdotal description of one mother's experience when taking their child to such a sort of clinic. Specifically, that they felt like they were being forced to transition their child, and obviously this is a concern. There is a case to be made that individuals from a very young age can be confident that they're in the wrong body. However, there is a much larger percentage of that population that isn't certain, and evidence is mounting that there are various other diagnoses or choices about sexuality that may instead be a more accurate description. For example, homosexuality, autism, and a few others. These are not conditions that require transitioning to, well, be done. Generally speaking, if homosexuality is the answer, then, well, they should be free to live their life however they want. There's no need for any further treatment. Certainly not anything that is surgical. Autism would be good with counseling, psychological support, and possibly medication, but that's generally to do with the anxiety and stress of their condition, not anything to do with their sex or gender. This is where the, let's say, article and the anecdote within it becomes something of a concern. The mother appears to have been pressured into putting her child, specifically a son, into the process of going down the pathway of transgendering through the use of puberty blockers, and that they were uncomfortable with doing this at the time. Now, part of the concern here is that she felt that the effect of the medication they were using led to a great deterioration in her child's life, and particularly the quality of life, leading eventually to hospitalization and an increase in the number of medications they were on. That's a worry in and of itself, and obviously most parents would feel similar, that they have questions about the appropriateness of treatment if it's adversely affecting their child's life like this. When they contacted the clinic to request, or more accurately demand, removal of the puberty blocking device, it was denied. The article does go through a great deal more detail, both on what the mother and son went through and other things again. The article raises many questions, whether you fall on one end or the other of the spectrum with regards to it. Primarily related to clinical evidence, or more accurately, evidence-based care, clinical guidelines, and, well, if they're being followed, or worse yet, not followed, that it opens the door to lawsuits. In other transgender news this week, we have the interesting news that Anheuser-Busch, the owners of Bud Light, have lost about 5% of their market share or market cap when they chose to bring Dylan Mulvaney in as a marketing symbol for Bud Light. They were trading at $66.73 per share. They lost 5% almost overnight following the choice of Dylan Mulvaney as a marketing symbol, let's say. Now, we don't think anybody should ever drink Bud Light. It is just piss in a can. The issue, at least for Anheuser-Busch, is that it appears that at least higher up in the food chain, people weren't aware of the decision that they would be working with Mulvaney, or at least according to the Daily Wire. And that's a concern, particularly if senior executives aren't aware of marketing decisions that have what is, to be blunt, a very negative effect on their market price. Stepping away from one minefield and into another, we have the purple tomato and why it is basically a symbol for the success of GMO foods. Now, the purple tomato doesn't seem like anything particularly exciting or interesting. After all, it's a tomato. An interesting color, but still just a tomato. The key here is that it was really only created in 1994, and that was by genetically modifying the tomato that existed at the time. Now, there were precursors to this that were also darkly colored, but a specific example here is what we're talking about. That is, a tomato that was made with the idea of increasing the number of anthocyanins. These are the same sort of things you would find in, say, blueberries. Now, where blueberries may only be available some parts of the year, tomatoes could be available in the other. And obviously, the more colourful your diet, as a general rule, the better off you are. In order to make the purple tomato, though, they had to take DNA from snapdragons and insert it into the tomato's genome. And this is how you got the colouring. Along with the unique colour, you also had a much higher amount of anthocyanin content compared to, say, blueberries. Although, this is not necessarily to say that the two are comparable, as a serve of tomato may be a very different size to a serve of blueberries. Other than the very obvious addition of beneficial anthocyanins, these also had a secondary effect. They increased the shelf life of these tomatoes compared to red tomatoes. This meant that you had longer-term storage options. And this is one of many possible applications of genetically modified food, not just to make them more nutritious, but to make them more stable and effectively to provide a better food security blanket of a kind anyway. Next we have an interesting article on economics, but specifically about bias in economics. The article looked at roughly 2,500 economists across 19 countries. They were trying to figure out whether or not there was an ideological bias amongst them, so they asked participants to respond to statements. They were either asked to respond to a mainstream source, or something with an ideological bent to it. They found that depending on where the statement came from, they could get an idea as to the Economist's point of view. What they found is that if they went with non-mainstream sources, economists had a much higher probability of disagreeing with them, about 82%. Now, this doesn't necessarily mean that economists are all biased and you shouldn't listen to them in any way, shape, or form, but as the authors note, it does indicate that economists tend to rely on authority rather than other sorts of information. In a piece of health news that we missed earlier in this video, we found that there's an interesting outbreak of a fungal infection in Michigan, and it's all related to a paper mill. 90 employees from the Upper Peninsula paper mill in Michigan have all been infected with fungus, and specifically a fungus that would normally be in soil and decaying wood. About 12 of them have had to be hospitalised. The condition is called blastomycosis, and it's interesting, purely because it's yet another disease that we would otherwise not have to worry about, because it's not normally something that will infect humans, suddenly infecting humans. It is important to note that it's unlikely that this was a human-to-human transmission pathway. Rather, there's a good chance that all of them were exposed to the same source, this most likely being some sort of wood product that hadn't yet been processed. If this is caused by a common source, and there's a good chance that it will be removed gradually, and if it's not from a common source, then it's entirely possible that the current protection methods of N95 masks and deep cleaning will resolve the issue. Next we go to news that would probably not surprise any civil engineer. That is, as you widen a freeway or highway, you don't actually get improvement in traffic conditions, you make them worse. The article specifically calls out the 101 in San Mateo County. This American freeway has been widened to accommodate more traffic. But how then, if you're widening it, has it led to greater congestion? And the answer would probably not surprise most people. By the time you finish widening that section of road, you're already over capacity. That's how long it takes to get there. And it's almost impossible to keep up with demand. Next we go to a very dumb article, and it's not dumb because of its content, but because of what it's demonstrating. That is, a man in a business responded to people, with presumably respect intended, by saying ladies, specifically in response to 2 ladies. Or at least 2 females. This was done as respectfully as was intended, and the same way they would respond, thank you gentlemen, or 2 gentlemen. Unfortunately, that's not appropriate under the various policies that are in effect in the East Hampton public school system. Apparently, ladies and gentlemen is not respectful and runs afoul of their diversity, inclusion, and equity policies. What they should be using instead, apparently, in order to be respectful, is not ladies and gentlemen, but instead y'all, everyone, folks, friends, and people. These aren't exactly professional phrases, and as such, that is an issue. And certainly, for someone who is in a position of seniority to other staff, using such language does seem condescending and rude. Why is ladies considered rude, you might think? Well, apparently it brings up ideas of patriarchy and similar, which is, in this instance, kinda bullshit. You might be thinking, well, this is a dumb situation, but really, if they're going to make a fuss over it, what's the issue? Unfortunately, the individual in question was offered a job, and then that job offer was rescinded because they were being respectful in an email. Yeah. Moving on to tech news and the hope that our eventual robot overlords won't have the same nonsensical views of the world, it's a analog or proxy for human behavior created through a sort of AI. The idea is that they've created a progressively more complex way of creating more interactions that are very similar to the way humans interact. The idea is that this, let's say, program would have interactions, record those interactions, and then use them to guide future interactions, and that this would continuously build on itself, creating more increasingly complex interactions amongst NPC characters within a very small scale system. We say small scale as it really only had 25 characters within a small town. These characters, or agents as they call them, moved around engaging and socializing. When that happened, they were then able to build on the memory they had, and so over a period of days, the agents or characters would interact and build on that knowledge and create more and more complex interactions, which is where things get really weird and, to a certain extent, creepy. For example, by stimulating one of these characters to want to have a Valentine's Day party, the other characters within this simulation then began to autonomously spread invitations themselves without having to have the controllers of this system instruct them to do so, but it also led them to seeking out other NPCs within this system and then make new acquaintances that way to bring them to that party. And this led to a really bizarre situation for us, in that it's a computer that is, for all intents and purposes, figuring out how to socialize. The next piece of tech news we have for you is more of an interesting response to the New York Times and, let's say, an article they published, although article may be a touch generous. The short version of it is that they were criticizing a crypto mining service for, well, using energy and then being paid not to use that energy when Texas needed that energy available for regular people to use. This is basically a hit piece. There is no real other description for it. Riot Platforms, which is the primary target of the hit piece, did respond to the article, and their response is fairly comprehensive, and you can read through it yourself. But some highlights we want to touch on in this video are that, to start with, they weren't being paid to not use electricity. They bid for the contract to stop using electricity, which they otherwise would be able to, so that that would then be available to the grid in cases of high demand or emergency. Secondary to that is that businesses like this have a constant, relatively steady demand, both during the day, when, for example, solar panels can generate electricity, but also when there's lower demand from houses. This ensures that something like a solar farm will continuously generate a profit throughout the day, even if there is no demand from regular consumers. That ensures stability of profit for these companies. If you have a stable consumer base, you don't need to charge as much because you get profit from all the power you generate and you're not wasting any. Where with a solar farm, you can't control how much is generated, something like a coal or gas plant can. They can spin up or spin down production. Renewables, not so much. But the other key to this is that by being able to constantly export power and make a profit, they can then reinvest in themselves, for example, with storage facilities, or a bigger plant, bigger farm, more turbines, or whatever else it happens to be. And this means more funding for renewables. Now, the criticism from the New York Times is that this company was paid money to not use that power, and that's not quite correct. They bid on a contract to wind down their use of power, so this was a competitive process, therefore they would get less money than just having a straight contract, but secondary to that, they had an existing contract to use or pay for so much power. Therefore, what they're getting back is not so much from the other users or consumers of electricity, but from their own contract. This means that they're not necessarily profiting, and they're certainly experiencing business disruption. If you want to understand more about this, please do read the full response by the service to the New York Times article. In similar technology news, but specifically focusing on renewables, is a slightly new design for wind turbines, and it's coming from the Netherlands. The turbine looks very different to your typical turbine, and that's because it's not really intended for large-scale commercial energy production, that being your massive plants you might see dotted across fields or in the middle of an ocean. Rather, this is intended for domestic energy production, that is something like a single house. The advantages to this sort of setup is that it generates no appreciable noise. It also doesn't have any real danger due to its much smaller size than compared to commercial turbines for things like birds and other wildlife. The turbine itself is relatively small, and we say that with some trepidation. It's about 1.5 meters in diameter and weighs less than 100 kilograms. So we are talking about something on par with a full solar array setup, just in a much smaller footprint. The advantages or disadvantages, depending on your location and circumstances, is that it can generate about 1500 kilowatt hours of energy each year, and that's with a relatively modest 5 meters a second speed of wind. If it was slightly faster, you would get more energy, and slower you would get less energy. The useful thing here is that you can distribute them over a large area, and by doing so, generate power, and that avoids much of the current problems, particularly if you live in countries that are somewhat reticent to embrace renewables, of having the environment tarnished by tall towers with massive turbines on them. At the same time, these do generate significantly less energy, so you have a much more widely distributed grid, which may or may not be beneficial as well. To use an example with Texas, where during their massive power outage only a few years ago, one of their big problems was that the supply lines for gas were fundamentally frozen solid. This prevented gas generation from being used for power. Their wind turbines were still largely working, and their nuclear was still largely working, but they lacked the necessary facilities to generate power otherwise. If you had something like this spread out over a relatively wide area, you might still be able to provide local energy even if the main energy suppliers, like power plants, were no longer operational. But that is a technical problem that's well outside the scope of what we are knowledgeable in. Further technology news has us looking at the New York Police Department and a tweet by the Chief of Transit, the Officer K5, effectively a semi-autonomous patrolling robot that's intended to help with the transit system. As you can imagine, this oddly shaped robot did not last very long before it wound up in a pond, or more likely a fountain in this case, which is not exactly conducive to robotics. We expect that this sort of thing is exactly why our future robotic overlords will not look kindly on humanity. Going next to what could be best described as physics news, although perhaps that's a bit optimistic, it's more likely to say this is incredibly confusing news. It's the discovery that gravity can create light. And yeah, this does sound as weird as it seems. The discovery is fundamentally that the gravity waves can basically shake space and time so hard that it creates radiation. Radiation, depending on which particular form it is either light or energy. The analogy used in the article might be easier to understand, and that is if you sit on a swing and you swing your legs back and forth, initially you don't move, but as you eventually move towards the right frequency, you begin to move the swing with your legs, and this is the action by which you impart energy into the swing from a stationary state. It's a similar idea with gravity, that gravity, through applying force to the universe and through time, generates light, and there's a much more complex process for that than there is to make a swing, swing. The next item we have for you is not so much news, but an interesting newsworthy item that we saw on Twitter, and it's called the potato paradox. It's a mathematical calculation that has a result that doesn't seem like it should be the right result if you're using an intuitive process. The general way it's summarized on Wikipedia is that if Fred has 100 kilograms of potatoes and that he leaves them out overnight, how much will they weigh the next day? What you're told is that they consist of 99% water, and that by leaving them out overnight, they drop to 98% water. The question is then, what do they weigh? The answer being, 50 kilograms. Now, this doesn't sound like it should be right. Now, this doesn't seem like it's right, but the Wikipedia article does explain how you get that result. One other way we saw of explaining it is that if you are taking a multiple choice quiz, if you have 99 answers correct or 99%, what would you have if you got 98% correct, or how many would you need to get wrong? Again, this may or may not make it easier to understand. The final bit of news we have for you this week is more crazy and weird than it is really useful. And it's a question about how many crabs would you need to be able to run Doom? Yes, the video game Doom. And the answer is about 16 billion crabs. This stems from the fact that you need about 8 crabs to run a logic gate, and you need so many logic gates per byte of data. From this, you can then calculate just how many crabs you need to be able to run a game or, for example, store a tweet. All of these things brought together means that, although it be very inefficient, you could indeed use crabs in what is perhaps the weirdest and most wonderful of ways. That's all the news we have for you this week. Thank you for watching. If you have found it interesting, consider liking, sharing, and subscribing. Please post any comments, questions, or suggestions you have below.